Hello again. In this lecture, we're going to explore what typecasting is and how to use NumPy's assignType method to do it. We'll begin by loading and displaying the dataset we'll be working with. All right. Typecasting, or simply casting, refers to the action of taking an object with values of a certain data type and creating an identical object that contains values of a different data type. In NumPy, this means creating a new array that stores the values of the original array under a different type. For example, we could be switching from decimal numbers to integers, or vice versa. This is best understood with an example. So let's use the assignType method to transform the floats of our array into integers. We do so by writing out the name of the dataset, followed by dot as type. Within the parentheses, we set the dtype argument equal to np.int32. To clarify, asType is short for assignType, dtype refers to data type, and np.int32 means we'll be using integer values up to 32 bits. The output is very similar to the original array. This time, there are no decimal points in the obtained values because every decimal value is now substituted with a corresponding integer. Good job! Going from floats to integers is easy, but floats aren't always what we'll need to convert into another numeric type. Sometimes, parts of the data come in the form of text strings, which look like floats or integers. However, since they don't store numerical values, we can perform limited operations on such data. So, let's see what we can do when our array is full of strings. We don't have such an array right now, so let's create one by casting the original array as string values. We write lending company data numeric dot as type and set the dtype argument equal to np.str, which is short for string. However, assignType doesn't overwrite the array in place, so we need to save the string array over the numeric one. We do this by setting lending company data numeric equal to the output of the assignType method. To confirm we've been successful, we can once again display the dataset, which should now contain text representations of all the numbers. As we are doing that, it's interesting how all the elements look like floats, but have quotation marks around them to indicate that they are strings. All right, we now have our array of strings, but did this alter the type of the lending company data numeric object itself? Or did it just assign a different type to its elements? We can check this by calling the type function. The output states that this is still an ND array, so we can move forward knowing that lending company data numeric retains all its ND array functionalities, while its elements are still string values. Perfect! Now we can proceed to trying to cast these strings as integers. Unfortunately, we get a value error message. The error states that these strings could not be converted into integers with base 10, which is the default base we work in. The reason for this is the decimal point. Since the dot is not an element recognized among integers, NumPy does not know how to cast it. Therefore, we can't directly cast these strings into integers. What we can try instead is transform the strings into floats first. Simply change int to float and rerun the cell. All obtained elements have decimal points, while none of them have quotation marks on either side, which proves that they are floats. If we really want to change these values into integers here, we have several different options. One is to overwrite the array as decimal numbers first, and only then cast them as integers. Superb! Another way to achieve this is to take advantage of NumPy's ability to chain methods. Before we try this, though, we need to recreate the dataset, storing all the decimal values as strings. To do so, we import the file without specifying a data type. Then we use the assignType method to convert it to strings. If we don't do this, we won't have the exact same array we had prior to overwriting it. This is important because we want to have the decimal points for each number. All right. So, in a new cell, we can paste the code we used to switch all the strings into floats. Then we can add another asType method and cast the dataset a second time. In this second method, we'll set the dtype argument to np.int32, and we should be good to go. As you know, Python executes code from left to right, so the second asType will be called on the output of the first. The outputs are once again integers, so this is a neat little trick we can use when necessary. Please bear in mind that this chain of methods doesn't overwrite the contents of our initial lending company data numeric variable. To see that's the case, just call the variable on a new line, and you'll see it still contains decimal numbers stored as text. Great work! Now that we've mastered casting and switching array values from one type to another, we're ready to focus on another way of handling text data, stripping. So, in the next lecture, we'll examine what stripping is and how to use it alongside other methods. Thanks for watching.